Hello, this is the problem I'll be doing for extra credit. Problem from homework 3, question 2. Basically, an op-amp problem. We have to find or relate an equation V out to V in. So first of all, we can start with the default behavior of an op-amp, where VP, where the voltage at the positive node and negative node are the same because they're shorted. So we could say Vp equals Vn, which is 0 volts. And so that means this whole node will be the same node right here. So that also means the current going through here is also 0 amps, because there's 0 volts. And therefore, if we do a KCL here, the only two currents that will play a part in this will be current going across the resistor, which I'll call I1, current going towards the capacitor, which I'll call I2. Now, so that KCL will be I1 plus I2 equals 0. And then you can define I1 pretty easily. I1 equals the voltage across the resistor over the resistance value. So voltage across would be this node, the blue node is VI minus 0 volts because that's ground. So VI, I don't have to include the 0, over R. That's for I1. And then to define I2, it is the current across the capacitor. This one's a little harder. So the equation for current across the capacitor is IC equals the capacitance times the derivative across the capacitor. It's just the derivative across the capacitor, but here we have two nodes with assumed separate voltages, so we would have to write it like because we're going from the currents running that way, higher potential to lower potential, so it would be capacitance times the derivative of Vi minus V out over dt. So we'd have to write it like that. Hold on. So I2 would equals C d Vi minus V out over dt. So that's pretty much that. Actually, I should write it like this: d over dt times this. Okay, well, it shouldn't matter. So we have the two currents defined. Now we can just plug it into this equation. So I1 is, I'm going to switch over here, VI over R plus I2 C D. Okay, I'm going to split them up, or I'm going to distribute the derivative part. So then that means it's going to be C times the derivative. Well, if I do split it, go dVi dt minus dV out dt. So that all equals to 0. And now I want to move that to the other side. Well, this C goes with both of them. Sorry. because okay, I want to also include the c's in here. So minus c equals 0. Okay, there we go. Now we want to move this term to the other side. So vi over r plus c dvi dt equals c dv out dt. There you go. Now we have it in terms of that. Could divide both sides by c. Well, divide all of it by c. This cancels, and then we'd have c here. So then vi over rc plus dvi dt equals dv out dt. And now we can start taking the integrals to get rid of the dt's. So we have to integrate all of it. That would get rid of this, which would leave us with, I'm gonna move this to this side because we're getting in terms of v out. So the integral, well, it's a definite, so it's from 0 to t. So I'm gonna include that. So the definite integral of v out from 0 to t equals this part, which is vi from 0 to t, plus this part, which vi stays in the integral, 1 over rc is a constant, it comes out. Let's go from 0 to t of vi. Oh, vi dt. Okay, so now that we got that, we need to expand these further down. So this is going to be v out of t minus v out of 0 equals v in, this is vi of t minus vi of 0. Also, vi of 0 is 0 because it is it's like it's a time thing. You only supply vi after t equals 0. So at 0, there's no voltage coming from it. So this is gonna, we don't have to include that. And so that's 0. And then this part is just plus 1 over rc over 0 to t vi dt. Okay, now we clean everything up. So get in terms of v out of t. So v out of t equals, we just have to move this to this side, that's about it. Equals v, this turns into a positive, v out of 0 plus vi of t plus 1 over rc, and the integral from 0 to t of vi dt. And that is our equation in terms of v out. And yeah, that should be it. That's the whole steps. All right, thank you.